So the next concept is clock multiplier, which is also called as frequency multiplier. So in frequency multiplier, whenever frequency is increasing, time period will reduce. So simply remember this relationship: frequency is inversely proportional to time period. When frequency is increasing, time period will decrease. When frequency will decrease, time period will increase. So frequency multiplier means whenever you are multiplying frequency, time period will get divided by the factor which you are using it here. Here I am taking as 2, so that's why I am getting here. Suppose if it is 4 times frequency, means time period will get divided by 4. So clock multiplier, which is also called as frequency multiplier. A clock multiplier is a circuit where frequency is increased and clock period is decreased for faster clocking rate. This technique is typically used in microprocessors and on internal buzzers so as to improve the overall throughput of the processor, and is generally used in conjunction with internal cache memories. So whenever frequency is increasing, time period is getting reduced. If you see figure 6.2, this is a simple clock multiplier. So it shows the circuit of a simple clock multiplier where the clock frequency is doubled. The circuit is simple implementation of clock and its delayed version. The delay can be introduced in the line by using buffers and inverters. So simply if you want delay, you can use here inverters as well as buffers. It is more common to use phase lock loop to achieve frequency multiplication. So here this is done by using an XOR gate. So for XOR gate, whenever inputs are same, output will be 0. If not, it will be 1. So first input is clock and delayed version. Whenever these two are given as input to XOR, I am getting output as CLK out. So let us try to understand this waveform. So you can see the same figure I have taken it here. Initially I am taking clock and delayed clock. So generally to get delays you can use either inverters or buffers. So this is a waveform which I am getting as delayed clock. So this is one input, this is another input. So whenever these two are given as input to XOR gate. So for XOR gate, it contains suppose two inputs A and B and output is Y. Combinations will be 0, 0, 0, 1, 1, 0 and 1, 1. So whenever inputs are same, output will be 0. If not, it will be 1. So by using the same concept, we'll get clock out. So here this is 0, this is 1. So inputs are different. So I'm getting output as 1. Next here this is 0, this is 0. Whenever inputs are same, output will be 0. And here this is 1, 0. Whenever inputs are different, output will be 1. And here it is 1 and 1. Whenever inputs are same, output will be 0. By using the same concept, you can get the output waveform, that is clock out. Now let us see how to write the constraint. So this part will be same. Please check the previous videos on create clock. So I'm taking a time period of 10 nanosecond here, that is at clock. This is the clock. Now I want generated clock at CLK out. So create generated clock, hyphen name is CLK out, hyphen source. From where it is coming from? This is coming from the clock port. So that's why hyphen source, get port CLK, and here I'm doing multiply by 2. So hyphen multiply by is a switch and 2 is the factor. And where I'm applying this? I'm applying this at the pin of XOR. So if you take XOR gate, here two input pins are A and B, output pin is Y. So you can take it like this. So here input names can be anything. So here in our example I am writing here as Z. Why? Because here this pin instead of Y it is Z. So that's why it should be written as get pins. XOR 1 is the instance name of it. That is XOR 1 followed by Z. So let me draw it clearly. So this is something like this. XOR 1 is the instance name and Z is the output pin name. So that's why I'm writing here as get pins XOR 1 Z. So this is the instance name. This is the pin name of the XOR gate. Or else you can give it like this also. Everything will be same followed by hyphen switch duty cycle. So generally here hyphen cycle 50%. So here I'm taking duty cycle as 50%. Means the time period for which it is on divided by total time period. Means it will be equally on and equally off. So on time period, this is off time period. So this is how we write the create generated clock constraint for clock multiplier.